Have you ever stopped to think about what actually happens in that tiny moment after you type your password and smack the enter key? I can tell you what doesn't happen. It's not just getting saved in some simple file. The real process is way more clever, way more secure, and it's all thanks to something called hashing. Let's get into it.
But first, let's just imagine a worst-case scenario. What if every website you use, your bank, your email, all your social media, just took your password and saved it exactly as you typed it, in plain, simple, readable text? What do you think would happen? Yeah, it would be a total catastrophe, an absolute security nightmare. A single data breach would expose literally everything. And to really get why that's so terrifying, we need to talk about something called the plain text problem. So, storing a password exactly as you wrote it is what we call storing it in plain text. It's just text, simple, readable, and one of the biggest security no-nos a company can make. Think about it. If a hacker manages to break into a database like that, the game is already over. They don't have to crack any codes or solve any puzzles. They just get a master list of usernames and their matching passwords. It's like finding the keys to every single house on the block just lying on the sidewalk. This is why we need a much, much smarter system. And that smarter system, our hero in this story, is called hashing. You can think of it like a digital meat grinder for your password. It's a clever one-way process that is really the bedrock of modern password security. Okay, so here's the core idea. Hashing takes your password and scrambles it into this long, unique string of characters called a hash. And the most important word here is irreversible. It's a one-way trip. My favorite analogy is this. You can turn a cow into a hamburger, right? But there is no way you are ever turning that hamburger back into a cow. That's hashing. You just can't reverse the process to get the original password back from the hash. So here's the play-by-play. When you first sign up for a website, you type in your password. The system immediately runs it through a special mathematical function, a hashing algorithm. And what comes out the other side is this secure hash. Now here's the critical part. The website stores the hash, not your password. From that second forward, nobody, not even the smartest engineer at that company, can see what your original password was. So then, when you come back to log in, the system does the exact same thing. It takes the password you just typed, zips it through the same hashing algorithm to create a brand new hash, and then it just compares that new hash to the one it has on file. If they match, boom, you're in. The website never needs your actual password ever again. But this system isn't quite perfect. There is a potential weak spot. So, what about those super common passwords? Password 123 or 123456. If the hashing algorithm always works the same way, wouldn't every single person who uses password 123 end up with the exact same hash? Yep, they absolutely would. And that's a huge problem because hackers are smart. They've built these enormous pre-computed lists called rainbow tables that are basically just giant dictionaries matching common passwords to their hashes. So if a hacker steals a database full of hashes, they can just cross-reference it with their rainbow table and find the original passwords for all the common ones. To solve that problem, security experts added a little secret ingredient to the recipe. It's a simple but absolutely brilliant technique called salting.
Salting is pretty much what it sounds like. Before the system hashes your password, it adds a unique, random string of characters to it. We call that the salt. And here's the genius part. This salt is different for every single user. Even if you and I both use the exact same password, we get different salts.
This changes everything. It means that if two people use password 123, one might get hashed as password 123 plus random salt A, and the other as password 123 plus random salt B. The result? Two completely different, totally unique hashes. This one simple step makes those giant rainbow tables practically useless.
Now, to make this as bulletproof as possible, there are a few rules of thumb. The salt has to be unique for every password, it should be nice and long, and it absolutely has to be random, not something predictable like your username. You do that, and security gets way, way stronger. Okay, so you've probably also heard people talk about encryption. It's another super important security tool, but it's really important to know that hashing and encryption are not the same thing. So what's the actual difference? Well, the biggest difference, the one that really matters, is reversibility. Hashing, like we said, is that one-way street. It's built for verification. You're proving you know the password without actually showing it. Encryption, on the other hand, is a two-way street. It's for secrecy. You use a key to scramble a message, and the person on the other end uses a key to unscramble it. You actually want to get the original data back. So here's the best way to remember it.
Hashing is for verifying that data is authentic and hasn't been tampered with, like a password. Encryption is for keeping the contents of that data a secret, like a private message. Okay, we've gone through a lot of the technical stuff, but let's zoom out. Why does all this matter so much for every single one of us using the internet every day? Well, it really all boils down to this. Good hashing protects us when data breaches happen. It helps companies follow data protection laws, it stops them from making that huge mistake of storing plaintext passwords, and it fights off major hacking attacks. But, beyond all that tech stuff, it does something even more important. It builds trust. You see, when a company goes to the trouble of using strong hashing and salting, they're sending a really clear message. They're showing that they are genuinely committed to protecting your digital life. It's not just about writing code, it's about respecting and protecting their users. So the next time you log into a website, just remember what's going on behind the curtain. The whole point of hashing isn't just to hide your password. It's to fundamentally transform it into something that makes it impossible for anyone, including the very company you gave it to ever know what it was. And in our digital world, that's pretty much the ultimate form of protection.